All right. Hi guys. In this video, I'm going to go over the solutions for the constant velocity algebraic problems. So if you have any questions, you can just follow along. Here we go. First up, we have, come on, 35 miles. Oh, why did it do that? That's not so great. "35 miles in 1 hour." And so we are trying to change to kilometers per hour. So in order to do that, we just need to have the 1 mile is equal to 1.6 kilometers. At that point, the miles have canceled, and we're left with kilometers on the top and hours on the bottom. So we just multiply across. 35 times by 1.6 is going to give you 56 kilometers over 1 hour, which equals 56 kilometers per hour. Next up, to get it to meters per second, it's easier to change kilometers into meters than to go from miles into meters. So we have 35 miles in 1 hour. 1 mile is 1.6 kilometers. Then I got to change my kilometers into meters. So 1 kilometer equals 1,000 meters. And I got to get my miles and I got to get my hours in a second. So 1 hour equals 60 minutes. And 1 minute equals 60 seconds. So double checking that my units are working out here. The miles cancel, kilometers cancel, so that leaves me with meters. Hours cancel, the minutes cancel, and that leaves me with seconds on the bottom. So our units are good. Just multiply all across the top. So 35 times by 1.6 times by 1,000 times by 1 times by 1 is going to give me 56,000 meters over 60. 1 times 1 times 1 times 60 times 60 is 3,600 seconds. So 56,000 divided by 3,600 is 15.6 meters per second. Okay. Lastly here, we got feet per second. So it's easier to go from miles to feet. So that's going to be 35. Oh, hang on here. Miles, 1 hour. In 1 mile, there are 5,280 feet. It's a little trickier to know. And then your hours, you got to change to 1 hour, 60 minutes, 1 minute, 60 seconds. Then, right, our miles have canceled, our hours have canceled, our minutes have canceled, leaving us feet on the top, seconds on the bottom. So 35 times by 5,280 times by 1 times by 1 is going to give us a lot. 184,800 divided by 3,600 seconds again. Feet, seconds. So divide. And you should get 51.3 feet per second. Cool, there we go. Next one. What must be your car's average speed in order to travel 146 miles in 3.25 hours? That part is easy, right? Velocity is just the distance divided over the time. So that's just 146 miles divided by 3.25 hours, sorry. So 146 divided by 3.25 is equal to 44.9 miles per hour. Kilometers per hour, so this is basically a repeat of part A, so that's just 44.9 miles in 1 hour. So in 1 mile is equal to 1.6 kilometers, and you get 44.9 times by 1.6 on the top. So that's going to give you 71.8. Units on that would be kilometers per hour. Kilometers per 1 hour. Okay, meters per second is going to be basically the same thing as part B above. Miles 1 hour. So we'll go ahead and we'll switch it. So we got 1 mile is equal to 1.6 kilometers. Then we got to change our kilometers, right? 1 kilometer is equal to 1,000 meters. Then change that, right? So now I got to deal with the time. 1 hour is equal to 60 minutes. And 1 minute is equal to 60 seconds. So now times by 1 times by 1 is going to give us, oh, and that would be here. If we take a look at this, we got miles are gone, kilometers are gone, should have meters on the top, hours are gone, minutes are gone, seconds are left on the bottom. Okay, so that should be meters. Oh, it's still over 3,600 seconds. That's going to give you 19 point, wow, 96, really 20 basically, right? Meters per second. All right, keep on going here. You are driving 60 miles an hour. How fast are you going in feet per second? Okay, easy enough. We got 60 miles in 1 hour. Man, we're getting good at this now. 1 mile is equal to 5,280 feet. 1 hour is equal to 60 minutes. 1 minute, 60 seconds. Right, we got our Miles are going to cancel, leaving us feet on the top. Hours are going to cancel with hours. Minutes are going to cancel with minutes, leaving us seconds on the bottom. So good. So we have 60 times by 5,280. That gives us 316,800 over 3,600 meters per second. And that's going to give us 88 feet per second. You look to the side for 2 seconds. How many feet did you travel in that amount of time? So, right, x is equal to velocity times by time. So we looked away for our velocity is 88 feet per second. So 2 seconds. So that is 176 feet. All right, now on to the meat type problems. So we have two locomotives approach each other on parallel tracks. One has a speed of 75 kilometers an hour and the other has a speed of 95 kilometers an hour with respect to the ground. They are initially trapped 8.5 kilometers apart. How long will it be before they reach each other? So I'm going to say that the one on the left, the red one here, I'm going to say that its initial position is 0 meters. And I'm going to say that this one's initial position is 8.5 meters, or 8.5 kilometers, I guess. Kilometers. Right, so I've now set up a coordinate system. So when I go to draw, write an equation for red train, I'm going to do XR for red is equal to, let's see here, 95 T plus 0. And green, blue, teal, let's just call it blue. B for blue. Right, it is going to be negative 75 t because it's heading in the negative direction, right? It's going to the left, plus 8.5 because it starts out 8.5 meters away. Now, of course, right, we want to know when do they meet, so we want to know when does the red position of the red train equal the position of the blue train. So that's just going to be, right, 95t is equal to negative 75t plus 8.5. I'm going to add 75t to both sides. So 95 plus 75 is going to give us 170t is equal to 8.5. Divide. 8.5 divided by 170 gives you 0.05. And you might say, hey, that doesn't seem right. That's 0.05 is really small. That's because it's 0.05 hours. So just in case we wanted to know it in minutes, because that's probably more useful, just multiply by 60, and that's 3 minutes. So in this case, it only asks how long it takes in time, not doesn't ask for the distance. So I don't need to do that. Two friends bring their dogs to the dog park. The doggies are super excited to see each other. Dogs are released from opposite sides of the 100-meter wide dog park. They run towards each other. The smaller dog runs 7 meters per second. The larger dog runs 12 meters per second. How far from the small dog does the small dog run before meeting up with his friends? Okay, so let's just draw this. Here's our dog park. Let's say this is where the small dog starts, and we'll call that 0. The reason I'm picking the smaller dog 0 is because I want to know how far from where the small dog is. So it makes sense to pick that as 0. If I did it the other way, I'd have um, one last step to do. And this is where the big dog starts over here at 150 meters. Write an equation for each one. So just do small dog, big dog. Small dog is equal to, it runs 7 meters per second, t plus 0, and big dog is equal to 12, but it's running backwards, so negative 12 t plus 150. So then set them equal to each other, so 7t equals negative 12t plus 150. Okay, add the 12t to the other side. So that's going to give us 19. And divide by 19. T equals 7.9 seconds. Keep in mind that we're not quite done because it does ask how far. So we just got to plug this back into one of the equations. So we'll just plug it back into that equation. To figure out how far the small dog has ran. And that's just going to be 7 times by 7.9. And that's going to be 55.3 meters. So that's how far the little dog had to run. Okay, cool. Last problem. I hope you enjoyed this. This actually happened. I did run late. So Mr. Molitor, Ms. Torres, and Mr. Crowfoot are going on a walk around Green Lake in typical Crowfoot fashion. It is true, I'm usually late. Mr. Crowfoot is running late, so Mr. Molitor and Ms. Torres leave without him. They did. I had forgotten my mask, so I had to drive home and get it. And so by the time I got there, they had already left. By the time Mr. Crowfoot gets to the starting point, Mr. Molitor and Ms. Torres are already 1,000 meters ahead. Mr. Crowfoot starts jogging at 5 meters per second, while Mr. Molitor and Ms. Torres are walking at 2 meters per second. Everyone is walking in the same direction in Mr. Crowfoot's shot. Okay, so always good to try to draw yourself a little picture. So right here I am at the start line, Crowfoot. Okay, here are Mr. Molitor, Ms. Torres, right? And they are 1,000 meters ahead, right? And we are all walking in the positive direction. I am going 5 meters per second, and they are going 2 meters per second. So let's write two equations here. So the equation for me is going to be 5 meters per second times by t plus 0 because I'm starting at the finish line. And we'll just put an m for Mr. Molitor. He gets to be the one in charge of the equation here. and he is going to be 2t plus 1,000. So, do note there is not a negative sign there because we are all going in the same direction. So because I'm going in the positive direction and Molitor is going in the positive direction, note they're both positive. So then set them equal to each other. So let's do that next. So 5t is equal to 2t plus 1,000. We got to get both the t's on the same side. So subtract 2t from both sides. And you're going to get 3t equal to 1,000. So t is equal to what? 333. So 333.3 seconds. Oh, come on now. Let's not do that. And then lastly, how far from the starting point is it? You can plug it into either equation. I'll just plug it into my equation, but it doesn't matter. And we are 1,666 meters from the start line. So a mile, basically. Okay, cool. I hope you found this helpful. Thanks for watching. Okay, bye.